Let's talk about graphs that have Eulerian circuits or Eulerian paths. So Eulerian circuits or paths. So remember, we know that a circuit is a path that starts and ends at the same vertex. When we say an Eulerian circuit or an Eulerian path, this is a circuit or path which uses each edge of a graph exactly once. So Eulerian touches edges, so those E's match. The nice part about Eulerian circuits and paths is that we have a condition that tells us when it exists. So a graph has an Eulerian circuit if every vertex has even degree. It has an Eulerian path if at most two vertices have odd degree. So here are four graphs, and we want to determine which of these have Eulerian circuits, which have Eulerian paths, and which have neither. And the way we do that is we just look at the degree of every vertex. So if we start with graph A, then we look at the degree of each vertex. So vertex A has degree 4, vertex B has degree 2, vertex C has degree 2, vertex D has degree 4, E has degree 2, and F has degree 2. So that tells us it has an Eulerian circuit. If it has a circuit, it has a path, because a circuit is a special kind of path. A circuit is a path that starts and ends at the same place. And so what we can do is just start somewhere and try to trace all the edges exactly once. We don't want to repeat any edges. And so this is just kind of guess and check. I'm just going to start here. I'm going to trace all the edges exactly once. And you can see that I started and ended at vertex A. So the path that I did, or the circuit A, B, C, D, F, A, D, E, A. If I look at graph B, I notice that each of these outer vertices has degree 1, and the inner vertex has degree 4. So this has neither a path or a circuit. There are too many vertices of odd degree in this graph. Okay, let's try C. So in graph C, this A has degree 3, B has 3, C has 3, D has 3, E has 3, F has 3, G has 3, and H has 3. Every vertex has degree 3. I cannot find a circuit or a path. And one more. 1, 2, 3. This has degree 4, 3, 3, 3, 4, 3, 3. Okay, so what we could do with this one is we have two vertices that are sort of bad, right? There's too many vertices of odd degree. So if we had an extra edge in here, we could add an edge, for instance, from, this vertex G has degree 4. If we added an extra edge, for instance, from vertex F to vertex B, then what that does is changes the degrees of these vertices to 4 and 4. So now what you notice is that there are two vertices of odd degree. So we would make those our starting places and our ending place and say that this guy has an Eulerian path. And we could start at C and just sort of travel along our edges trying not to get stuck anywhere. And notice that I ended at vertex D.